This chapter is all about subdivision surface modeling, which can be used for organic objects like characters, or really any highly detailed object that has smooth, rounded shapes. We've already looked at adding the subdivision surface modifier before, but what I haven't mentioned is that there's an even faster way to do it. If you're in object mode, you can just use the hotkey Control 1 through 5 on the top row of number keys to add a subdivision surface modifier of that level. So I'll select the cube, hit Control 3, and now it has a subdiv of level 3. If there already is a subdivision surface modifier, then those hotkeys can switch the viewport level of that modifier, but only if the mouse is hovered over in the 3D view. So you can see over here in the properties editor, it's not doing anything. But in object mode, in the 3D view, we can use 1 through 5, as well as Control 0 to turn off the subdiv completely. Be aware that this is just for the viewport level and not for the render level, so you'll have to set that separately. One of the things beginners do with subdivision surfaces is set it too high. This slows down everything, and it can slow it down quite a lot, because increasing the level by 1 increases the poly count exponentially. To show you this, I'll go over to my overlays and turn on statistics. And here we'll look at the triangle count, which is the number of polygons sent to the render engine. With a level of 0, we only have 12 triangles, 6 square sides being split into 2. With a level of 1, we jump all the way to 48 triangles. With a level of 2, we have almost 200. With a level of 3, we're at almost 800. 4 jumps us all the way to above 3,000. And 5 jumps that up to above 12,000. So even a single number difference can make a huge impact on your performance. So what you really need to know when working with subdivision surfaces is how detailed you need this object to be and where more subdivisions stops making a difference. For example, if I right-click and shade smooth and zoom out a little bit, the difference between 4 and 5 is completely negligible. But by increasing it, we're adding 9,000 polygons that we don't need. So what you want to do is view this from wherever you're going to be seeing it in the render and decrease the level until you can actually start to notice a difference. Here, the edges are way too jagged at 2, so I could bump this up to 3. Now, whether you'd need 3 or 4 in this case is subjective, but when in doubt, err on the side of lower resolutions. That's going to save you a lot of headache. We already looked at this a little bit before, but you can also set the subdivision surface modifier to simple if you don't want the new geometry to be smoothed out. In the previous example, we added a simple deform modifier, and while using the simple type of subdivision, that allows us to flex this cube pretty well. Without the subdiv modifier, then we just get a garbage result. So if all you need to do is just add geometry without changing the shape, then the simple method is the way to go. For the vast majority of this course though, we're going to want to use the Catmull-Clark method, which rounds everything out really nicely. The benefit of using the subdivision surface modifier is that it allows us to edit a really low poly shape very quickly to do what would otherwise be a very slow operation. For example, if I wanted to extrude out this front piece, all I need to do is just take it, let's say inset it a little bit, and then E to extrude a bit more. Let's make some dumbbell looking shape. So I'll E to extrude, scale that up, E to extrude that more. And that operation was incredibly fast to do. But if I were working with all of that geometry in edit mode, like if I took this and hit Shift D and just applied this modifier, even at this pretty low level, making that same operation would be really difficult. I could E to extrude, but then I don't get that smoothing in between, and I could use proportional editing and add in these edge loops separately, but that all takes a lot of time. So the main purpose of the subdivision surface modifier is to keep the base geometry as simple as possible while still allowing us to get a smooth and more complex result. Now, oftentimes when you're working, you're going to want to sharpen up some of these edges. We've already looked at this a little bit before, but as a reminder, the two ways to do that are by adding edge loops or by creasing. So with the edge loops method, we can hit Control R, and the closer we slide this to that edge at the end, the sharper our result is going to be. You may need to add edge loops around both sides of an edge. So in this case, if we wanted this to be really sharp, we'd want to select this face and also hit I to inset, such that there's another edge loop running all the way around. This method works really well and gives us the most amount of control, but the downside is that we now have all of this extra geometry running around the object. For example, on this side, I could take this edge and move it along the x-axis, and everything else follows naturally. But if I do that same thing here, I can't just grab this single edge and move that out. I'd have to move this one and that one. Okay, well that's not too big of a deal. I can also just move that. But now these are sitting at the wrong angle. I'd have to go into front view here, move that back into place, and as you can see, this just becomes a much bigger hassle. So another thing that you can do besides manually adding edge loops is add creases to these edges. I'll do that on this side here. I'll select the edges that go all the way around, and then let's go to the sidebar, go to the edges data, and increase the mean crease, which is the average crease. You can also do that in the edge menu by hitting Ctrl E, or by right-clicking while in edge select mode and choosing edge crease, or using the hotkey Shift E. So that's pretty fast to get to, but you'll notice that the shading here isn't very good. If we turn on our wireframes by going to our overlays and wireframes, and maybe turning down the opacity here, and also in the subdivision surface modifier, turning off optimal display so we actually see all of the resulting edges. I'll even turn this up by 1. You can see that we now have on this left side a bunch of new geometry that's all concentrated around that edge. Whereas on the right side, we're getting a sharp angle, but we don't have any of that extra supporting geometry. So since we don't have all of those extra edge loops that run alongside this edge, we're just stretching the existing vertices to fit that shape. However, if you go to object mode and right-click and shade auto smooth, and you don't care about having a little bit of a rounded edge, then this can also work pretty well. We can transition from a completely smooth shape to a completely sharp one. Then you can also add a bevel modifier after the fact if you want to, or add a bevel in the shader like we talked about in the video about bevels. It's also worth noting that you can crease vertices as well. So if you wanted this face to match exactly with the face in edit mode, you could take the mean vertex crease and turn that all the way to 1 as well. Now this face is the same shape as in edit mode, but subdivided with more geometry. You can also crease vertices without creasing edges if you want to, and make a pillow-like shape by selecting some vertices and increasing the mean vertex crease. Though oftentimes this doesn't look super great because again it's just stretching the geometry and not adding any new geometry there that's concentrated around that detail. So if you push that too hard, it doesn't look too good, and you really have to crank up the levels, which is often a bit of a waste of poly count. But when making certain objects, vertex creasing can be helpful. Another great option for sharpening up edges is with the bevel modifier. So I'll go ahead and add one of those just by going to add modifier and typing in bevel. And then this one I'm going to place above the subdivision surface modifier. So that's going to sharpen up all of these edges. Now if I hide the subdiv modifier, you can see the result. And so it makes sense that when I pass that to the subdiv modifier, it's going to sharpen up everything. Now what I want to do is set up the bevel such that it mimics what we did over here on the left by adding all of these supporting edge loops, but without us having to worry about those getting in the way in edit mode. So I'll hide the subdiv modifier for now, and let's take the bevel and increase the segments. That way there's one right in the middle, and we're getting an edge running along the top and the side. Then we want to go to Profile and turn the shape all the way to 1. That way there's no difference in the shape between turning on and off the bevel, it's just that we get those extra edges. Then if you want to be more specific about which edges are getting beveled, set the limit method to weight. Then I'll go ahead and turn on the subdiv modifier, and then when we select some of these edges, I'll select this edge loop that goes all the way around, and turn up the mean bevel weight. We get some nice sharpening, with the benefit that this edge is now extremely easy to manipulate, and we don't have to worry about all those extra edges cluttering things up. So sometimes this is a great way to work. It doesn't necessarily work for every situation, but for something simple like this, it's often a great way to go. You can adjust how sharp it is just by adjusting the bevel weight. Another thing I'd like to point out here is that when we talked about this smooth by angle modifier in a previous lesson, I mentioned that the modifier itself is definitely slower than making the same adjustments in edit mode. So since we're adding so many polygons with the subdiv modifier, it'd be much better to just get rid of this smooth by angle modifier and instead just select these edges, like so, and in edge select mode, right click and mark sharp. That'll give us the same result with much better performance. And you can also do this really fast, regardless of how complex your creases are, just by selecting one, and then going to Select, Select Similar, or Shift G, and choosing Crease. Then in the Redo panel, you have a ton of different options to choose from for which creases get selected. A couple other things I want to mention about the subdiv modifier is that while it's really good for high poly modeling, it's obviously not the best at low poly modeling. So you wouldn't take this shape and export it straight to a game engine. So for low poly stuff, you might use it to get, a couple interesting transitions from one shape to the next, but it's never going to be the final result. And lastly, while this is a bit more of an advanced tip, if you're making characters or objects that are going to be animated and have both a high poly and a low poly visualization, it's really helpful to model them in a certain way such that the low poly roughly matches the high poly. And here's what I mean. If I go into edit mode here, you can see that the final result is not really close to what the low poly looks like. And if all I care about is this final result, then that's perfectly fine. We don't need to do any extra work just for the sake of it. But let me show you another example with a plane. Let's hit Shift-A, add mesh and plane. I'll hit Tab to go into edit mode. And let's just take both of these edges here, E to extrude along the Z-axis, and let's scale this out. All right, then I'll go to Object Mode and hit Control-3 to add a subdiv modifier of level 3. Notice how both the high and low poly versions are pretty much touching the ground, and there's not a huge visual difference of seeing this at level 1 versus level 3. Of course, the quality is higher, but when it comes to what parts of the surface are contacting the ground, it's not really changing. So this is a pretty good low poly object. However, if I were to merge these together, let's just scale them to 0 along the x-axis, M and merge by distance, and then add some subdiv here, you can see the difference between the low poly and the high poly version is much bigger. And so if we were to try to animate this in its low poly state, and I animate this so that it's exactly touching the ground, well, when I turn on my subdiv, then that animation is kind of ruined and things don't connect the way they should. So when it comes to modeling for animation, especially for bendable and posable objects, try to at least have a flat surface on those points of contact so that the high poly and low poly better match up. And it's less confusing for animators when they toggle this on and off. At the beginning of your modeling journey though, that's not something I expect you to be worrying about. So for now, just practice adding the subdiv modifier via hotkeys and sharpening up edges with the different methods that I showed you in this video. Once you've got that down, then head over to the next lesson and we'll do some modeling.